time for another video. Today, let's talk about concentration. Well, we already referred to concentration a little bit in class last time. So as far as what concentration is, well, concentration just basically answers the question of how much stuff is in how much space. So, for example, if you're the sort of person who likes iced tea, for some reason I don't, even though I've lived in Texas my whole life, I can't stand it, you can make a really dilute iced tea, or you can make a really concentrated iced tea. You can even buy a little tiny jar that's just concentrated iced tea. It's about maybe 50 milliliters, and it's enough to make gallons and gallons and gallons of iced tea. That would be very concentrated. So that's going to be the difference in between dilute and concentrated, which is different actually from the difference of a saturated solution versus an unsaturated solution, which has to do with something called solubility, which we will talk about later on in this section about solutions. There are two main methods of measuring concentration that we will use in our book. That's going to be molarity, that's going to be the more common one, and also something similar called molality, which is not as common but has a very important use, as we will see. We're going to start with molarity. So, molarity is basically going to tell us the moles of solute in liters of solution. So you're going to have moles of what you dissolved over liters of the solution. Very important to note, it's not just the liters of the solvent, it's the total liters of the solution after it's been made. So let's see if we can do this. You prepare a solution that contains 90 grams of sodium chloride in 3.5 liters of solution. What is the molarity of this solution? Go ahead and pull out a piece of paper and a calculator, something to write with. See what you can do with this problem. Go ahead and pause the video. So, once you've taken a look, let's see if we can do this together, and if you got stuck, maybe we can clear it up. So let's think of what we have at first. Well, we know we have mass, and that mass is going to be 90 grams of sodium chloride. We also know that we have volume. We have the volume of the solution, which is 3.50 liters. Well, this is all fine and good, but if we remember, molarity is going to be moles over liters. So mass isn't going to do us much good. We're going to need moles. And oh, what's that? You remember how to turn mass of a compound into moles of a compound. Good. Go ahead and do that if you have not done that already. So we'll do 90 over 1 times, and that's going to be grams there, times 58.44 grams in 1 mole. Grams cancel, so we'll have 90 divided by 58.44, giving us 1.54 moles. Okay, great. Now we've got moles and we've got liters. 1.54 moles divided by 3.50 liters is going to give us 0.440 molar. Simple as that. That is molarity. Now, of course, it's not truly as simple as that. There's got to be something more complicated. What if we wanted to dilute something? What if we had a certain concentration of solution and we wanted to make it less dilute? We actually did this in the PhET simulation we played around with in class. We could add more water to something, or you could make it more concentrated by evaporating the water away, and it did change the properties of the solution. But let's say we wanted to dilute something. Well, we would need an equation to do this. And actually, this equation is very simple. It's just like Boyle's law, but for solutions. Now, what could that mean? Think for just a minute and see if you could write an equation that could help you change 1 molarity into another in a very similar way to Boyle's law. And what you should have gotten is M1V1 equals M2V2. It's just like our P1V1 equals P2V2, and it works the exact same way. Let's try it. You're going to take 500 milliliters of a 2 molar solution and of glucose, or anything really. What it is does not matter in this context, and you're going to dilute it down to 1 liter. What is the new concentration? Okay, go ahead and give that one a shot. And we'll start with a fresh new page. We know that we have, hang on, I guess I need to turn back on my pen. We know that we have an original molarity of 2 molar. We know that we have an original volume of 500 milliliters. We know that we have an ending volume of 1 liter. And we know that we're looking for our ending molarity. Well, take a look here. We've got milliliters and we've got liters. Since it's 2 different unit systems, we're going to have to convert one to the other. I always like going down if I can. So 1 liter into milliliters. King Henry died by drinking chocolate milk, and that's going to give us 1,000 milliliters. Great! Now we'll just use our dilution equation. It does not have a cool name like Boyle's law or Charles' law as far as I know. So we'll do 2.0 times 500 equals x, it's our unknown, times 1,000. Let's see, doing a little bit of math here, x tells us that it's going to be 1.0 molar. Alright, now some of you may be saying, hey, I could do that in my head. Well, maybe so, but I picked easy numbers here for you the first time. It might not always be that easy. In fact, it probably won't be. Last concept for today then, molality. Molality is very similar to molarity, except it's going to be moles of solute, same thing as it was before, over the mass of the solvent. Not even of the solution this time, just the mass of the solvent. And it's going to take a lowercase m, where molarity had an uppercase m. For reference, since I mentioned in class, 99.9% of our solutions will be in water, it turns out that if you have 1 liter of water, that is equal to 1 kilogram of water. So that's a useful thing to keep in mind. So let's try one. 2.5 moles of sucrose are dissolved in 2.0 liters of water. What is the molality of that solution? Give it a shot. Okay, and let's see what we had. Well, we know that we had the number of moles. We had 2.5 moles of sucrose. Let's see, what else did we have? Well, we had our volume, which was 2.0 liters of water. But remember, molality equals moles solute, which we have, our sucrose, over mass, in other words, kilograms of solvent. And liters is not kilograms, but we do know the conversion. 2.0 liters, and we know that our conversion, let's see here, is going to be in every 1 liter, there's 1,000 grams, or 1 kilogram. Let's leave it in kilograms since that's our SI unit. So 2 times 1 will give us 2.0 kilograms. So then 2.5 moles over 2.0 kilograms will give us 1.25 molal. Again, usually we'll be using molarity, but there are a few notable situations in which we'll need to use molality, including making ice cream shortly in the future. So that's the motivation there. You're going to need that to make ice cream. That's it. Don't forget the whisk.